Hi everyone, this is the second video for the first day. In the previous video we looked at sectors, and this video we will be looking at segment. Recall that a segment of a circle is a figure formed by an arc and the chord joining the endpoints of the arc. Sector was arc and two radii. So for example here OACB would be a sector, but ABC is a segment. Why? Because it's an arc and a chord joining the endpoints of the arc. Now, one simple way to find the area of this segment is that it's going to be the area of the sector OACB minus the area of triangle OAB. So what we are doing here is reducing the problem into two other problems which you already know how to solve, which is finding area of a sector and finding area of a triangle. Now let's look at a strategy for how to find the area of this triangle. Now let's see, what kind of a triangle is it? If you take this triangle OAB for any chord, OA and OB are going to be equal. Why? Because they are just the radius of the circle. Well, what kind of triangle is that? That is an isosceles triangle. So let's say case 1, the height of this triangle is given. Say OA equals, OB equals 5 and OD equals 4. Now this case is fairly easy because if the height is given, then the area is simply 1/2 times base times height, right? And we already have height. This is 1/2 times base times the height is 4. But we got to figure out the base. But we know that this is 4 and this is 5. Then I can find this using Pythagoras Theorem. And by use of Pythagoras Theorem, this is going to come out to 3 centimeters. So AB is going to be 6 centimeters. Why? Remember the property that if you take a chord and you drop a perpendicular from the center of a circle to the chord, that bisects the chord, which means AD equals BD. So this area is 1/2 times 6 times 4, which is 12 square centimeters. So that's case 1 when the height is already given to you. Case 2, the height is not given, but the length of the chord is given. So you have AB equals 8, and then you have the radius is 5. Now in this case again, the area is simply 1/2 times base times height, except you have the value for the base in this case, and you do not have the height. So we use the same trick in reverse. You drop a perpendicular, call this point D. This is 5. Now if the entire length is 8, then this length is going to be 4. Why? Same reason. Drop a perpendicular from the center of a circle to a chord that bisects it. Again, by Pythagoras, this is going to come out to 3 centimeters. So the area is 1/2 times 8 times 3. It's 12 centimeters squared. Once you have that, you already know how to find the area of a sector. You can use the area of sector, subtract the area of triangle to get the area of the segment. Okay, let's look at an example. There is a pattern shown here. We have to find the area of this pattern. Now, first of all, whenever you see an irregular shape, the goal would be to try and break it down into two regular shape. So this is going to be area of the rectangle minus area of the segment. Now remember, the area of segment itself, the calculation involves a subtraction, right? This is area of sector minus area of triangle. So let's go step by step. Let's work on this first. The area of the sector, I noticed first that these are in degrees and minutes. So I'm going to first convert this completely into degrees. So I divide the 18 minutes by 60, plug that into the calculator and add it to 130, and it gives me 130.3 degrees. So area of sector is going to be 130.3 over 360 times pi 22.05 squared. I plug all of these numbers into the calculator. Again, remembering that I need to use the pi button on the calculator. This gives me the area of the sector to be about 552.85 square centimeters. Now let's look at the triangle. What do we know about the triangle? Right here, we have the two sides. Can I find the side length of this side? Now, if you look at the rectangle, then you will observe that this is just going to be 56.18 minus 10 minus 10. So from this full length, I'm taking out this left bit and the right bit, which will give me 36 comes out to 36.18. All right, so I know the side and I know the two radii, which means recall that the strategy I can use is drawing this perpendicular, knowing that this is 22 point. So the strategy that we use will be the one where we have this side is 22.05. This is going to be half of 36.18, so it's 18.09, and using Pythagoras we can find the height, which is going to be square root of the hypotenuse squared minus the other side squared, which comes out to, when I plug it to the calculator, 22.05 squared minus 18.09 squared, and the square root of the answer is, when you round it, 12.61 centimeters. So the area of the triangle is going to be 1/2 times the height, which we just found, times the base, which is 36.18. And that comes out to 18.09 times 12.61, 228.11 centimeter squared. So the area of the segment itself is 552.85 minus 228.11. 552.85 minus 228.11, which comes out to 324.74 centimeter squared. So the required area, right? So let's say the shape area is going to be, we have to find the area of the rectangle and subtract this segment. And the rectangle is easy, it's 56.8 times 25.16. Right, so area of rectangle is 56.8 times, what was it? 56.18 and 25.16. So it's 56.18 and 25.16. Subtract 324.74 and plug that into the calculator. Times 25.16 minus 324.74. And that comes out to 1088.75 square centimeters. So that's going to be the area of the pattern. That's it for day 1. You can attempt the worksheet and then verify your answers by looking at the solution.